Welcome to the course on reading house plans. We'll help you understand the relationship between what you see in the house plan and what physically happens in the construction of the home. Here's a more in-depth look at what we'll cover. How to provide accurate quotes based on the plans. You'll understand the difference between a load-bearing and non-load-bearing wall. And by the way, we don't discuss this with the client as designers. We leave that up to the architect, structural engineer, or a licensed contractor. But at least with the knowledge to understand what a load-bearing wall is, we can begin to work on our plan while the client verifies that the wall is a supporting wall or simply a partition wall. Also, the photographs in this course aren't from the actual home being built in the sample house plan we're going to use. The photographs are meant to help in explaining the information on the house plan. All this can be found in the PRL Residential Construction and Systems in Chapters 6 and 7, covering the foundations through the floor level. We'll also use some information in Chapter 3 of Kitchen and Bath Design Presentation, another part of the NKBA Professional Resource Library. Before we start, I want to make sure that you understand how to use a scale. While most of the building industry uses the architect scale, NKBA has adapted the scale for use by kitchen and bath designers. Most of the building and design industry works with feet and inches and a scale of 1/4 inch equals 1 foot. That would be logical when you're trying to get the entire building on one piece of paper. But as kitchen and bath designers, we work with single rooms, and because of the detail required for a completely documented kitchen and bath project, we use a bit larger scale, or the scale of 1/2 inch equals 1 foot. And we work in inches only, not feet and inches. If we look at the architect scale at the top, we notice that 0 is 12 inches from the end of the scale. Any dimension less than 1 foot will be measured to the left of 0. Then to the right of 0, we'll have our 1 foot increments. Once again, that's using the architect scale. Below the architect scale, you'll see the NKBA triangle with a similar 1/2 inch scale. Notice that since the kitchen and bath industry works in inches only, we start at the extreme left side of the scale at 0, and every inch is marked, which makes it easier for us since we measure and design in inches only. Let's look at the 54-inch blue line at the top. The starting point is 6 inches to the left of 0 plus 4 feet to the right of 0. Therefore, the total length of the blue line is 54 inches when using the architect scale. You can see it's easier to measure the same distance when we're using the NKBA triangle. We start at 0 and 6 inches beyond 48 inches would be 54 inches. If you're used to an architect scale, it may take a little time to get comfortable using the NKBA template triangle. But after you use it a few times, you'll probably find it easier to use since you'll be measuring your projects in inches. The NKBA template triangle works just like a tape measure. The plan we'll be using is for a ranch with a walkout basement. As you can see, the detail is almost impossible to read because we've reduced a large house plan down to a size that will fit on your screen. The bottom left corner in the highlighted area is the scale. It's noted as 1/4 inch equals 1 foot. Typical of a house plan. We've redrawn this plan, eliminating a lot of the details so that we can highlight areas we'll be discussing. Then we'll enlarge the original plan to show the detail. Let's start in the back left corner of the home. The first thing we want to do is discuss how dimensioning a floor plan will be different than dimensioning a kitchen and bath drawing. A good way to illustrate this is thinking about the inside of the garage area. Imagine your client would like to add some storage units. They've asked you for a price on some of the Gladiator metal cabinetry and shelving. The dimension on the floor plan is 21 feet 4 inches. However, on close inspection, we realize this is an outside of the house to the center of the bathroom wall dimension, not inside space available for the Gladiator units. We'll have to do a little math to determine the exact space available on the inside of the garage before we can calculate the available space for the storage units. We'll start with the bathroom laundry area. We notice that the draftsperson drawing this plan has noted the wall is a 6-inch wall. Another term for this wall is a wet wall. Right behind the toilet is a 4-inch vent stack. Of course, the 4 inches is an inside dimension, which would make the stack outside dimension closer to 4.5 inches. Since a 2x4 stud is actually less than a perfect 4 inches, the 4-inch stack wouldn't fit in a standard stud wall. Therefore, a 2x6 wall is constructed in some areas of the home. It's not a coincidence that the vanity, toilet, and washing machine are in the left side of the bathroom. All of these appliances and fixtures use water. Now that we know that this wall is made up of 2x6s, we can start solving our math problem. In the photograph on the right side, you'll see that a double vanity and toilet have their plumbing in a 2x6 wall. The first thing we need to do is convert feet and inches into inches. Therefore, 21 feet 4 inches would be 256 inches from the outside of the block wall to the center of the 2x6 wet wall. The nominal size for the 8-inch block is 8 inches. Half of a 2x6 is 2 3/4. And then there's half-inch drywall. Remember to add the half-inch drywall on each side. So the total there is 11 3/4, which you would deduct from the original outside dimension of 256. That leaves us with a balance of 244 1/4 inches of space for the Gladiator storage units. And the math assumes that we won't have any finished covering on the block wall to the left. The exercise we just completed would be used to estimate the amount of storage space as opposed to ordering based on a house plan. Now, a lot of things can change once construction begins on a house. If you understand the house plan, you can make very accurate quotes if the home is built exactly as that plan states. Reality check, however, that rarely happens. Here's Rachel with a series of math problems.
Let's do another math problem. In this particular situation, the client has asked you for cabinetry on each side of the window. The first thing we need to do is find the overall space from finished drywall to finished drywall. But we notice that the 5'10" dimension is from the center of the 2x6 wall to the center of a standard 2x4 stud wall. We convert the 5'10" to inches only, which is 70 inches. Then deduct half of the 2x6 stud wall and half of a 2x4 stud wall. In this situation, we did not deduct the drywall, so we would subtract another inch for half-inch drywall on each side. This would leave us with a total finished wall to finished wall dimension of 64.5 inches. Next, we would deduct the width of the window to determine the size of the cabinets that would fit on each side. We need to look for the opportunity to add items that would be both helpful to the client and additional profit for our company or your company. This wet wall has a lot on it, with plumbing, both supply lines as well as drain waste vent lines packed into this short wall. A wash station in the garage would certainly keep the rest of the house much cleaner, particularly for a person that loves to work outside or in the garage. Everything we need to plumb a sink is found in this common wall. The plan we're using includes 3 pages. On the first page, you will find elevations of the home. Since there is more detail on the front of the house, including the brick veneer on the lower portion, the draftsperson chose to show the front of the house on a scale of 1/4 inch equals 1 foot. But the other 3 views of the house were reduced, so all 4 views would just fit on one piece of paper. To do this, the draftsperson chose to use a scale of 1/8 inch equals 1 foot for the 3 remaining views. Notice the sliding glass door on the lower level, which is access to the basement at the back of this home. And there are no steps leading down from the deck to the ground. This info will be important later on. Here is an isometric view of the lower level of this home. As a reminder, the floor plan we are looking at is drawn to a scale of 1/4 inch equals 1 foot. We will start in the rear corner again, but we will look at information about the footing and foundation of this home. This is an enlarged image of the corner you saw previously. The long broken line represents something you cannot see but would be below ground. In this case, in the red boxed area, you'll notice that the broken line represents a 16-inch wide by 8-inch deep concrete footing. This home is far enough south so that the footing is deep enough to get below the frost level in this warmer climate. As an example, the footings in Chicago would be 48 inches deep. Also, in the boxed-in area, you will notice the notation 8-inch block. This is the size of the concrete block to be used for the back of this home. Because the back wall is open, the only load on this wall is from the top of the upper level of the home. This is not the case at the front of the house. Here's an example of how the footings are laid out and reinforced. In this warmer climate, the footing is not as deep and rebar is used to add strength to the footing. After the rebar is in place and lifted slightly off of the base of the trench, concrete will be poured into the trenches. The finished footing for this project is on the left. The 16-inch wide footing is built to hold 8-inch wide block. Typically, the footing is much wider than the foundation wall resting on top, just as our feet are bigger than our legs. We will now focus on the front foundation wall. Do you see that it seems to be visually thicker than the rear foundation wall? To see the difference, we have to look at the actual plan. In the elevation view, it appears to be one level when viewed from the front, but two levels when viewed from the rear, since a load at the front of the house will be both vertical as well as horizontal. In other words, the field dirt pushed up against the wall will need to be thicker. In the red box, notice that the footing is now 20 inches wide instead of 16 at the rear, and the block is 12-inch block as opposed to the 8-inch block in the rear. This is a good example of a home that will be open on the rear of the basement level, similar to our house plan. Instead of block at the rear of this home, an exterior stud wall will be added. The field dirt will then be pushed tight against the wall when the home is complete. I want you to notice three things in this picture, starting at the bottom of the 20-inch wide footing, which is wider than the 12-inch block resting on the footing. Above the 12-inch block, we see 8-inch block, which will be faced with a brick veneer for the full height of the foundation wall. Once the brick is in place and dirt is pushed up against the foundation wall, it will appear that the entire wall is brick. Instead, it will be a brick veneer on 8-inch block, but the 12-inch block gives support to the brick all the way into the footing. Here, we notice that the brick has been waterproofed at and below ground level. In addition to concrete block, foundation walls can also be made of poured concrete. Here's an example of that. Metal forms were placed with rebar in between. Next, the hollow space between the forms were filled with concrete. Later, the forms are removed and voila, you see the finished wall. Let's take a look at what the floor will be for the basement. It's noted in that yellow portion and says, the floor will be a 4-inch concrete slab with 6x6 reinforced wire with a plastic moisture barrier. This will be poured on top of a 4-inch layer of crushed rock. Here is an example of the plastic moisture barrier covering the crushed rock. The plumbing has been roughed in according to the house plan, and the floor is now ready for concrete. Here's the same floor after the concrete was poured, and construction on this level is ready to begin. In a previous photo, you may have noticed that parts of the plastic were recessed in certain areas. Well, these areas would indicate where load-bearing walls will be placed once framed walls are added for the first level. In our plan, we see that notation in the wall separating the back of the house from the front of the house. The slab is to be thicker in an area 16 inches wide and 8 inches deep. This thicker portion of the concrete slab will act as a footing for interior load-bearing walls. In one circle, you will see the recessed area and rebar following the direction of the trench. In the second circled area, if you look closely, you'll notice a wire support that will lift the rebar out of the bottom of the trench to allow concrete to fully encase the two sections of rebar. Once the wall is in place, it would look like the wall in this photo. At the top of the wall, floor joists are resting on top. This is an indication this will be a load-bearing wall. More on this later. The wall in our plan will not run the full length of the house. Instead, it will stop once it reaches the garage. Inside the garage, the wall will be replaced with 2 steel columns that will support the remaining floor joist. Within the red boxed area, we see that a 3.5-inch pipe column will be resting on a 24 by 24 by 12-inch deep concrete footing. This is one of the 2 columns that will be supporting a beam in the garage. In the red box area, we see the notation for the 2 pipe columns resting on the 12 by 12 footings. Replacing the wall in the left side of the basement will be 3 2 by 10s, creating a beam which will carry the weight of the overhead floor joist. The 2 by 10s will rest on supports at each end of the garage and on top of the 2 pipe columns. This home will use the basement type of foundation. However, there are other types, as you see here. If the terrain is not perfectly flat, a slab on grain foundation would be appropriate if the home is built on a concrete slab. For homes built on level land, a grade beam foundation is typically used if a crawl space or basement is not necessary or practical. In coastal areas where tsunamis and other high tides could drive waves inland, homes are often built on piers. The home in this photo was actually built on the north side of Oahu, Hawaii, where surfers find some of the highest waves in the Pacific. The final type of foundation would be the crawl space. Now that we've covered the construction of the floor and the walls in the basement, let's move on to the level above. If we're standing in the family room and look straight up during construction, we would see floor joists. That info can be found on our plan in the red box area and tells us 4 very important things. We would be looking at floor joists, which are 2 by 10s. They will be placed 16 inches on center and run in the direction of the rear of the house to the front of the house. Here's the notation aligned with the picture of the floor joists. We see the notation 2 by 10, an arrow, and then 16-inch OC, which means the joists are 16 inches apart, center of joist to center of joist. 2 other types of joists used in home construction are the trussed joist and manufactured joist. These may cost a little more than the floor joist used in our plan. However, the span is often greater, and in case of the trusted joist, our load-bearing wall in the middle of the basement may not be necessary. Once the joists are in place, the subflooring will be added to construct a platform that will become the floor of the next level. In the illustration on the left, we notice an example of the beams that could have been used to support the joists in the garage area. In the garage area, the joist would be resting on top of the beam, not connected to the side of the beam. The support for the beam could be provided at each end of the garage and by our 2 pipe columns. The photograph on the right illustrates how the floor joists are supported beyond the garage area. The subflooring is placed perpendicular to the direction of the floor joist. This will help keep the flooring area square. Subflooring is typically either OSB, oriented strand board, or plywood, and is considered a structural material. The finished flooring is typically placed on top of an underlayment, which will rest on top of this subfloor. We are now ready to start the exterior and interior walls. Information about walls can be found in Chapter 8 of Kitchen and Bath Residential Construction and Systems. To help you understand, here is an isometric view of the main level of this home. Notice the 3 bedrooms, 2 baths, the combined foyer, living room, and dining room area, as well as the kitchen. The exterior walls are to be built using the standard 2x4 studs. At the bottom will be a single bottom plate with a double top plate above. Some type of corner bracing will keep the walls from shifting left or right at the top. Openings, such as doors and windows, will need to have a header to support the missing studs. The walls are built on top of the platform horizontally and then stood up and braced until the next platform or roof is constructed. This type of framing is called platform frame construction. An illustration for this is in the top right. In older homes, you may see balloon frame construction. Instead of individual walls, a continuous stud would go from the foundation wall to the top of the home and be connected to the roof framing material. This type of construction left a hollow space between the studs and could become a hazard if a fire were to break out in the basement of the home. There would be nothing to stop the fire from moving rapidly from the basement to the attic. We turn now to our friends at Chief Architect to help illustrate how to identify some of the points mentioned, such as exterior and interior walls, when reading a digital house plan.
Hey, this is Adrienne with Chief Architect. Let's look at this floor plan. It looks like the dimensions for this plan don't snap to the surfaces of the walls, and they're formatted in feet and inches. So this number, 21 feet and 5 inches, might not be something we can rely on if we were asked to add some storage to this garage. To make sure that we have an accurate reference of the space available, we'll draw an interior dimension that spans the entire space. Let's zoom in and examine this. You can see the original dimensions are snapping to the corner of the wall, which is the structural layer. In this case, it's concrete block. Over here, the dimensions appear to be snapping to the centers of the interior wall. Our new dimension is snapping to the surface of the finishes, so we know that we have just over 245 inches to work with as we design. If I turn on these dimensions for the interior wall, we'll also notice that the dark gray wall is 6.5 inches wide and the light gray wall is 4.5 inches wide. Because this thicker wall is part of the laundry room that has a toilet, sink, and a washing machine, it seems pretty likely that it's a wet wall and that there's plumbing and a soil stack in here with the wall framing. Let's look at some of the other walls in this drawing. These outside walls with the dotted line indicate that there is a foundation footing underneath the wall. We can see that these walls have a bigger footing than this wall at the front of the house. This is probably because the house sits on a sloped lot and the wall on the downhill slope has to carry more load. The interior wall running through the center of the basement also has a dotted line indicating that it has a footing too, and it's a load-bearing wall. This dotted line going through the garage tells us that there's a beam spanning the space. And these two squares indicate concrete footing pads that are supporting posts under the beam. Along with other notes that you'll find in plans like these, it's common to encounter a key like this wall legend. This can make it easier to map and understand the construction methods being used in the design. And that's how you read a floor plan. Remember, as a kitchen and bath designer, you shouldn't be informing your clients which walls they can and cannot remove. Let's leave that to the architect, structural engineers, and licensed contractors. However, understanding the difference between load-bearing and non-load-bearing walls will help you with the early stages of planning for your kitchen and bath designs. Looking at our floor plan, can you figure out which of these walls are non-load-bearing? I have a few clues. In the basement, the garage beam and the structural wall were centered in the space. This means any load-bearing walls should be directly above the basement beam and wall. Also, load-bearing walls that are supporting the roof load would need to continue the entire length of the house. Neither of these walls are that long. While it is possible to have beams replacing walls, as we've seen in the basement, no beams are indicated in this plan. When I turn on my reference so we can see the walls below, notice that neither wall is directly over the load-bearing wall in the basement. Is it possible that the ceiling and the roof could be supported in a manner other than interior load-bearing walls or beams? The clue can be found in the original plan. Let's take a close look at that information noted in the master bedroom. There's a little note with some very valuable information, such as prefab trusses will be used, and an arrow that indicates their direction from the front of the house to the rear of the house. The third bit of information is the spacing for the trusses, which will be 24 inches on center. Manufactured truss joists come in different shapes and sizes, like we see here. They're custom designed for each home and for the load that would be placed on the building. The weight of the trusses are transferred to the front and the back exterior walls. Therefore, all of the interior walls on the main level of this home will be non-load bearing. There are some walls in this home that shouldn't be relocated. For example, the wet wall for the hall bathroom. It's directly above the wet wall in the basement, so if you were to alter this wall, you'd be dealing with a continuous soil stack coming from the concrete slab all the way through the roof. A major change to the plumbing in this wall would be very expensive. Thanks for tuning in. This is Adrienne Stevenson with Chief Architect, and that's how you identify a load-bearing wall.
The house plan will also give us information about the windows and doors. Additional information can be found in Chapter 9 of Kitchen and Bath Residential Construction and Systems. The only openings other than garage doors in the basement area of this home would be a sliding glass door leading out of the family room and a small window in the bathroom. We'll start with the bathroom window. The window is noted as a 2030. Keep in mind that construction plans are in feet and inches. Therefore, the window required for this opening would be 24 by 36 or 20 by 30. Beside the plan illustration, I've added an example of a window that would fit this dimension. The actual dimensions of this window would be a ½ inch less in width and height than the rough opening suggested on the plan. This gives the framer the opportunity to make sure the window's plumb and square within the opening. The window we're looking at would be in the concrete block wall, while the other windows in the home would be within the wood framing. The builder would be looking for windows to fit the rough opening noted in the plan. That means it's always slightly larger than the actual window or door. Here are two examples of the window installed before trim is added. Notice a slight gap between the jamb of the window and the rough opening. Kitchen and bath designers often make a mistake when reviewing a house plan and calculating window and door sizes. They assume the dimensions on the house plan will be the finished dimensions on their kitchen or bath plan. As this illustration shows, that will not be the case. Here's an illustration of the edge of a window and a rough opening created by wood studs. A finished jamb, noted as item number 1, would be applied to the side of the stud. Once drywall is added to the stud, a piece of trim, item number 2, covers the gap between the jamb and the drywall. By the time we plumb the window up, add the trim, and a slight reveal, we'd end up with 3 additional inches on each side of the finished window. The lesson learned here is that a 24-inch wide window, noted on a floor plan, could end up being 36 inches wide on a finished kitchen or bath plan. The entry into the downstairs bathroom shows a door dimension of 2'8", which is actually 2 feet 8 inches wide by 6 feet 8 inches in height. Some quick math would show us that this is a rough opening for a 32-inch wide door. By the time the trim is added, the CAD size for your finished bath plan would be close to 38 inches, not the original 32. Very important. In the kitchen, the person who drafted this plan has a 30 by 30 inch window or 36 by 36. Very typical for many kitchens. Once your finished plan is drawn, the window space including trim would be somewhere between 40.5 and 42 inches, depending on the trim size. The 3 remaining openings include a door to the exterior, which is 2'8", a cased opening on the bottom, which is also 2'8", and the third opening into the dining room is simply the space between the end of a wall and the inside of an exterior wall. That dimension scaled out to be approximately 36 inches. The master bathroom on the main level will have a little extra space due to the fact that it's bumped out over the foundation wall. That area is noted on the basement plan with a long dashed line. In the red box, we notice the following: cantilevered floor joist, 16 inches on center, plus a directional arrow to indicate the joist will be running parallel to the existing joist floor. These cantilevered joists could be longer joists only in this area, or additional joists tied onto the existing joists, which is common in a remodeling project. The photograph on the right is a good illustration of the cantilevered section of the master bath shown on our plan. On the left, we see how the cantilevered floor joist would appear if additional joists were added. The method in the red area is simpler than a cantilevered area that would be perpendicular to the floor joist. On the right is how this bath area might look during construction. You're measuring the kitchen for cabinets before the window and door trim have been installed. What should you do before finishing the job site measure? A. Plan for 3-inch trim to be safe. B. Plan for 4-inch trim to be safe. C. Check with the contractor for the trim size. D. Assume 2 1/4 inch trim since it's the most popular. The answer is C. Never assume, always check with the contractor for trim size before finishing the job site measure. Your client is planning on relocating a toilet. The first question to ask should be, A, are you planning to reuse any existing fixtures? B, what's below the bathroom? C, will this bathroom have a shower? D, are you sure the door will stay open with the new configuration? The answer is B. The floor construction and the space below will dictate what kind of plumbing relocation can or can't be done. We briefly mentioned the type of roof construction for this home. Additional information on that can be found in Chapter 10 of the Kitchen and Bath Residential Construction and Systems. We'll review the highlights now. This was our notation in the master bedroom indicating the type of roof construction for this home. Prefab trusses are custom designed for each home. Flat ceilings or cathedral ceilings and even hip roof construction is possible with prefab trusses. A conventional stick-built home would be constructed with rafters at an angle and ceiling joists running parallel with the floor. Since a joist could not span the entire distance from the front of the home to the back, notice the intermittent load-bearing wall in this illustration. On the left, notice how the prefab trusses were anchored to the exterior walls. On the right, you'll notice a lot of bracing will be needed until the trusses are anchored together. As we finish up, let's take a look at some of the things in the kitchen area that we should pay attention to when designing this client's kitchen. Here's an enlargement of the original floor plan depicting the kitchen area. Depending on your experience, you may have noticed some omissions and errors in this plan. It's very possible that you know more about kitchen design than the draftsperson who created the plan. The deck area has been highlighted. There are no steps leading from the deck to the level below. Double check the rear elevation, and no steps were indicated in those drawings either. So these are the little details, okay, big detail, you want to look for when you're reviewing a house plan. On the surface, it may appear that the easiest way to bring equipment into the home is through the kitchen door, but in this case, it'd be impractical. However, the deck would be a good place to set up a miter saw and complete some of the dirty work. The next thing you might notice is that the appliances aren't conveniently located and wouldn't pass many of the NKBA planning guidelines. The sink should be in the center of the other two major appliances, and the space between the refrigerator and range should be at least 27 inches when combining landing areas. As you look at the plan, you'd want to remember to order a dishwasher end panel or base end panel for the extreme right side of the kitchen and allow enough space to the left of the refrigerator to open the door greater than 90 degrees. Take notice of the electrical noted on the plan. Make sure the draftsperson's plan for under-cabinet task lighting. You should now feel comfortable reviewing a house plan and know what items to look for when doing your kitchen and bath designs. This allows you to provide an accurate quote and maybe even suggest products or services the client didn't originally consider. And you should be able to determine if a load-bearing wall is present on a house, and in many cases after the home is built. Well, up next, we'll cover how to measure kitchens and baths, know the best time during the design process to measure, and what to pack in your toolkit. Yep, you're going to need one of those. All that's coming up next.
The information included in this course and each of the 150 questions on the AKBD exam are drawn from the NKBA Professional Resource Library volumes. It is highly recommended to study the books prior to sitting for the exam. The books, as well as a study guide, exam prep flashcards, and a practice exam are available for purchase in the NKBA online store. The Professional Resource Library books and the NKBA Kitchen and Bathroom Planning Guidelines are also available in ebook format at Wiley.com and other online retailers.